A 15-kilometer corridor of the Earth's crust has cracked open under Iceland. Not a single mountain, not a classic cone-shaped volcano, but an entire tectonic seam. As of this year, a stretch of land that was silent for 8 centuries is now in a state of continuous rupture. Over 10 eruptions have occurred since March of 2021. 7 of them have happened in just the last 12 months. The ground itself, in the town of Grindavík, has sunk by more than a meter, tearing roads and houses apart from below. This is not an event. It is a new geological state of being. And the central question hanging over the North Atlantic is not if the next eruption will happen, but when, and whether it will trigger the same paralysis that brought global aviation to a halt in 2010. To understand what is happening now, you have to understand the memory of April 14, 2010. That was the day the volcano Eyjafjallajökull, a difficult name for a global nightmare, entered its main explosive phase. It erupted underneath a 200-meter-thick glacier. The result was a catastrophic chemical reaction on a planetary scale. Molten rock at over 1,000 degrees Celsius met freezing glacial meltwater. The magma flash cooled and shattered into microscopic shards of silica glass. This was not smoke. It was an airborne abrasive injected directly into the jet stream, right at the altitude where commercial airliners fly. Dr. J. Michael Davis, an aeronautical engineering professor at Purdue University, has explained the physics with chilling simplicity. When this volcanic ash enters a modern jet engine, it doesn't just pass through. The engine's combustion chamber operates at temperatures high enough to melt the silica. The ash turns back into molten glass, coating the delicate turbine blades and fuel nozzles. The engine chokes, starves, and fails. There is no workaround. There is no flying through it. The consequence was the largest shutdown of air traffic since the Second World War. For 6 straight days, the skies over Europe fell silent. Eurocontrol, the European Organization for the Safety of Air Navigation, had no choice but to ground everything. Approximately 100,000 flights were canceled. 10 million passengers found themselves stranded in airport terminals, on hold with airlines, suddenly cut off from their destinations. The global airline industry, according to the International Air Transport Association, lost an estimated $1.7 billion. The total economic damage, factoring in lost trade and productivity, climbed towards $5 billion. A single Icelandic volcano, shrouded in ice, had held the modern interconnected world hostage. And now the ground in Iceland is tearing apart again. But here is the detail that changes the entire story. The eruptions unfolding across the Reykjanes Peninsula are not happening under a glacier. They are fissure eruptions. The crust separates and lava flows out. It is visually spectacular, apocalyptic even. Fountains of molten rock reaching hundreds of feet into the air. Rivers of orange fire consuming the landscape. But it is not producing a significant ash cloud. The deadly ingredient from 2010, the glacial ice, is missing from the equation. Keflavik International Airport, the nation's primary hub, sits just 10 kilometers from some of the active fissures, and it has remained fully operational. The flights are still taking off. The chaos of 2010 is not repeating itself. The strangest part of this story, then, is not the eruption itself. It is the fundamental misunderstanding of the threat. The world is watching for an ash cloud that is not coming, and in doing so, it is missing the much more localized, more insidious crisis unfolding on the ground. This is the part the headlines do not capture. Iceland is not facing a repeat of Eyjafjallajökull. It is facing something new, a protracted war of geology against infrastructure, a battle against the land itself. Zoom out, and the tectonic reality makes the mechanism clear. Iceland exists because the Mid-Atlantic Ridge, the great seam where the North American and Eurasian tectonic plates pull apart, rises above sea level. This is one of the only places on Earth where a mid-ocean ridge can be studied on dry land. The Reykjanes Peninsula, in the southwest corner of the country, is the point where that ridge makes landfall. It is a landscape defined by this constant stretching, a process that moves at a steady 2 centimeters per year. For centuries, this tension built up. The last major eruptive period on the peninsula, known as the Reykjanes fires, was from 1210 to 1240. And then for approximately 800 years, the system fell dormant. The plates kept moving, but the magma stayed below. That silence was shattered on March 19, 2021. An eruption began at Fagradalsfjall, in a valley named Gjalldin-Gjallir. It was the first sign that the long slumber was over. Another eruption followed in August 2022 in the Maridalr Valley. A third began near Litli Hrútur in July of 2023. These were events, tourist attractions even, but they were precursors. They were the system waking up, stretching, preparing for the main event. In November 2023, the nature of the threat changed entirely. A massive earthquake swarm began. Over 1,000 tremors were recorded in a single day. Scientists at the Icelandic Meteorological Office, the IMO, realized magma was no longer just finding small vents. It was moving horizontally, forming a massive underground tunnel, a dike 15 kilometers long, and it was running directly beneath the fishing town of Grindavík, home to 3,800 people. At its shallowest point, this river of molten rock was just 800 meters beneath the surface. The order was given on November 10th. Evacuate the entire town. This is where the story of Grindavík truly begins. The residents did not just flee from the threat of lava flowing over their homes. They fled as the very ground beneath their feet began to fail. As the magma dike shifted and drained underground, it created voids. The surface above it began to sink, not by inches, but by feet. In some parts of the town, the ground subsided by more than 1.5 meters. Roads that were flat on Friday were broken and useless by Saturday. Deep fissures, some wide enough for a person to fall into, opened up in gardens, across streets, and straight through the foundations of homes. Houses were not burned. They were torn in half by the planet itself. Vidar Reynisson, the head of Iceland's Department of Civil Protection and Emergency Management, faced a crisis with no modern precedent, a town being geologically dismantled from below. And then the fire came. On December 18th, 2023, the pressure underground became too much. A 3.5 kilometer long fissure opened in the Sundhnúkur crater row, north of the evacuated town. Fountains of lava confirmed the scientists' worst fears. The eruptive cycle had begun a new, more aggressive phase. This was the first of 7 eruptions in this specific area over the next year. On January 14th, 2024, a second, smaller fissure opened right on the edge of town. Lava flows crept into the northernmost streets, consuming 3 houses. The images were stark. Orange lava consuming a suburban home, a symbol of a community being erased. But the town of Grindavík was not the only thing at stake. Just 4 kilometers to the northeast of the town sits the Svartsengi geothermal power plant. This is not just any power station. Operated by the company HS Orca, it was built in 1978 and provides 75 megawatts of electricity and 150 megawatts of thermal energy. It is the source of hot water and heat for approximately 30,000 people across the Reykjanes Peninsula. Its failure would mean a regional crisis in the depths of an Icelandic winter. Adjacent to it sits one of Iceland's most famous landmarks, the Blue Lagoon, a luxury spa that draws tourists from all over the world. Now, here's the part nobody is putting on the news. The Blue Lagoon is an icon of Icelandic natural beauty. It is also entirely artificial. Its milky blue silica-rich waters, famous for their skin-healing properties, are the wastewater effluent from the Svartsengi power plant. The entire complex, a critical piece of national infrastructure and a crown jewel of the tourism industry, sits directly on top of one of the most active volcanic zones on the planet. During the eruption of February 8, 2024, lava flows cut the main hot water pipeline running from Svartsengi, threatening the region's heat supply. The flows also advanced directly towards the power plant itself. The threat was existential, and it triggered one of the most remarkable engineering battles in modern history. Even before the eruptions began, based on seismic data from the IMO, construction crews had started a desperate race against time. Bulldozers, excavators, and dump trucks worked around the clock, 24 hours a day, under the strange glow of the aurora borealis, illuminated by the eruption itself. Their task: to build massive earthen walls, protective berms up to 5 meters high, designed to physically divert rivers of lava. Over 20 kilometers of these barriers were constructed around Svartsengi and the Blue Lagoon. It was a primal contest. The most advanced engineering versus the most fundamental force of nature. And during the eruptions of March and May 2024, the barriers were tested. Thermal cameras and drones watched as incandescent rivers of basaltic lava at temperatures between 1,100 and 1,200 degrees Celsius smashed against the newly built walls. The lava pooled, rose, and then, just as designed, was deflected, flowing parallel to the barriers and away from the critical infrastructure. It was a victory, but a temporary one. The magma beneath the surface was still accumulating. The barriers had won a battle, not the war. This new reality is what Dr. Matthew Roberts, managing director at the Icelandic Meteorological Office, is talking about when he says the Reykjanes Peninsula has entered a new eruptive period. His models, based on the historical precedent of the Reykjanes fires in the 13th century, suggest this cycle of regular eruptions could last not for years, but for decades, possibly even a century. The rapid-fire succession of eruptions in 2024, January 14th, February 8th, March 16th, May, 29th, August 22nd, November 20th, is not a series of isolated events. It is the new rhythm of the region. The interval has collapsed. Much like the Florida lake in the reference story that went from draining every 20 years to every few years, the geological clock in Iceland has accelerated dramatically. The question is no longer if an eruption will threaten Grindavík or Svartsengi, but how many times a year the defenses will be tested. There are other stranger phenomena emerging from this new era. During the more explosive phases of the fissure eruptions, when lava fountains spray molten rock high into the air, high winds catch the cooling droplets. They are stretched into long, impossibly thin glass fibers. These threads, which can be meters long but thinner than a human hair, are known as Pele's hair, named after the Hawaiian goddess of volcanoes. They are razor-sharp silica. They can drift for miles, blanketing the landscape in a fragile, glassy wool. They pose a severe respiratory hazard and can cause skin and eye irritation. It is a rain of volcanic glass, another bizarre feature of this erupting landscape. The scientific effort to understand and predict these events is immense. The Icelandic Meteorological Office, in collaboration with the University of Iceland's Institute of Earth Sciences, has wired the entire peninsula. A dense network of seismometers, GPS stations, and gas detectors tracks the land's every move. Satellite radar imagery measures ground deformation down to the millimeter, allowing scientists to see the land inflate as magma accumulates below. Dr. Paul Einarsson, a professor emeritus of geophysics, and Dr. Christine Jonesdotter, natural hazards coordinator at the IMO, are part of the team trying to translate this torrent of data into actionable warnings. They track the seismic precursors, the thousands of micro-earthquakes that signal magma on the move, giving the Department of Civil Protection the crucial hours needed to sound alarms in clear areas. It's a system honed by fire. As Viðar Reynisson has stated, the response becomes more efficient with each new eruption. They have learned to live with this unfolding disaster. But the sheer volume of magma is staggering. During peak activity, some of the 2024 fissures produced lava at flow rates exceeding 1,000 cubic meters per second. That is enough to fill an Olympic-sized swimming pool every 2.5 seconds. When a fissure several kilometers long opens up, it unleashes a torrent that can reshape the landscape in hours. This is the force the engineers are trying to contain with earthen walls. This is the power that has put the 3,800 residents of Grindavík into a state of permanent displacement, their futures uncertain, their homes either destroyed, damaged, or sitting on ground that could split open at any time. This forces a reevaluation of the entire concept of risk. The 2010 Eyjafjallajökull event was a logistical and economic disaster, a short, sharp shock to the global system. It was solved by waiting for the ash to clear. The current crisis on the Reykjanes Peninsula is something else entirely. It is a chronic condition, a geological disease that must be managed day by day for an unknowable number of years. It doesn't threaten the engines of jets flying at 35,000 feet over Germany. It threatens to systematically dismantle a corner of a country, to erase a town, to cut off power and heat for tens of thousands, and to force a continuous, grinding, expensive battle against the planet's internal heat. The experts have made the distinction clear. Dr. Norvaldur Þórðarson, a professor of volcanology, has repeatedly emphasized that these are effusive fissure eruptions. They are spectacular, lava-producing events, but they are not the ash-producing phreatomagnetic explosions that occur under ice. Yet the headline, "Air Chaos Persists," a ghost of 2010 that distracts from the real, immediate drama, the drama of a community that has lost its foundation, the drama of engineers building walls to hold back a liquid mountain, the drama of scientists trying to predict the breaking point of the crust. And then there is the existential question buried in the geological data. If a tectonic system that was dormant for 800 years has reawakened with such intensity, what does it mean for the long-term future of human settlement in this region? The entire Reykjanes Peninsula is cross-hatched with similar volcanic systems. Krýsuvík Trollhättingja and Brennisteinsfjöll lie further east. The current activity is centered on the Sundhnúkur crater row within the Svartsengi volcanic system. But the entire peninsula is alive. This is not one monster. This is the monster's lair. Tonight, the situation is deceptively calm. The last eruption in November 2024 has ended. Seismic activity has decreased, but it remains significantly elevated compared to the baseline before 2021. GPS data shows the ground around Svartsengi is once again beginning to swell, a clear indication that magma is recharging the chamber a few kilometers beneath the surface. The machine is resetting. The barriers are still standing. The town of Grindavík is still empty, a modern Pompeii waiting not for rediscovery, but for the next assault. The international airport is still open, a symbol of a crisis contained and a crisis misunderstood. 3 questions hang over the peninsula tonight. How long can the engineered barriers hold against the geological cycle that scientists predict will last for decades? Why, after 800 years of silence, has this tectonic corridor awakened with such extraordinary force and frequency? And what does it mean for a modern society to live not near a volcano, but on top of a 15-kilometer-long rift that is actively tearing the world apart? The magma that will fuel the next eruption is right now somewhere beneath the moss-covered lava fields of Reykjanes, accumulating in the dark. It is rising, pressurizing the rock, searching for the next point of weakness in the crust. The seismometers are listening for its first movements. The engineers are inspecting their earthen walls, and somewhere in the fractured ground under Grindavík, the next fissure is waiting its turn to open. The warnings from 2010 were,